Hi, I'd like to discuss a framework for looking at the energy of a system. So, as just a reference, when we say system in physics, we mean some smaller part of some greater universe. And from the framework of system, it implies that there are sort of two places, what we call inside the system and what we call outside the system. So any interaction that's happening inside our system boundary, we would say is internal. Anything happening from an interaction with the outside would be external. Now, in terms of energy, there are two or three, depending on how you think about it, classifications for how energy can occur. So, one way of framing it is to think of energy into two categories. There's the energy of motion, which we call kinetic energy, and there's the energy that is associated with work done by conservative forces, or more generally, the energy associated with work done by an interaction of a physical field, which means work done by one of the fundamental forces, which we call potential energy. Now, the third classification that we could use is saying that inherently, when we say kinetic energy, when we say potential energy, we truly mean external kinetic energy, the motion of the system as a whole, and external potential energy, the change in field energy or the stored field energy of the system as it currently stands. Internal energy also has kinetic and potential components. One aspect of internal energy is the energy associated with temperature. And as we'll get to in chapter 21, as we talk about thermodynamics, thermal energy is 100% about motion. Kinetic energy, specifically when we take a look at ideal gases. As we look at more complicated systems, then that internal energy can also involve energy of structure, which all molecules, all atoms, all sort of pieces that we consider real matter are held together through electrical interactions using the electromagnetic force, which has potential energy associated with that. So what we call chemical potential energy or binding energy in chemistry applications are really just a form of internal potential energy of a system. Even mass itself is an internal potential energy associated with the nuclear forces. So what we are going to do in our framework is we're going to use this sort of three-tiered approach. When we say kinetic energy, we mean the motion of a system as a whole, whether it's organized by translational motion or organized by rotational motion, an object moving around a coherent center. When we say potential energy, we mean potential energy of the system as a whole. And internal energy is energy that is inside the system, either through temperature, through bonds, through the mass of a system. It's sort of all of the other energy that is, but it's contained within the boundary, not being sort of modified by interactions that happen at the boundary of our system with the greater world. Now, in terms of those interactions, there's 6 ways that we could transfer energy from our system to the outside world or from the outside world to our system. And the first we talked about in chapter 7 with what we call work. Work is a transfer of energy using a force that is displaced with the system. So anytime a force has a displacement with a system, then that force transfers energy. If it's in the direction of the displacement, it adds energy to the system. If it's against the direction of the displacement, it removes energy from the system. As we get into the later chapters in Physics 1, chapters 18, 19, 20, 21, we'll start talking about the second transfer of energy, heat. And heat is a transfer of energy associated with objects having a different thermodynamic temperature. And that thermodynamic temperature goes into this internal energy that I talked about a moment ago. So a positive heat is energy being added to a system, and negative heat is energy being removed from a system. Adding by having the system being at a lower thermodynamic temperature than the outside world, or at a lower state of order compared to the outside world, and removed by either increasing the order of a system or sort of taking thermal energy from inside that system and passing it into the outside world. Now, before we get into heat, we're actually going to talk about mechanical waves as we cover chapters 15, 16, and 17. And a mechanical wave is an oscillation or vibration that carries energy from a system to some other part of the universe. Another form of transfer is kind of a trivial form of transfer, what we call mass transfer. So for example, if my system is this board, I could take some of the mass of this board and I could move it to another system, somewhere off camera. Moving that mass, because as Einstein's equation famously says, mass is energy, that's a form of energy transfer. There's also energy associated with electrical transmission that is kind of tied into changes in internal energy, and we'll look more into electrical transmission as we get into Physics 2, looking in chapters 22, 23, 24, 25, 26, 27. Now, the last way that we can exchange energy is through the process of electromagnetic radiation. And any exchange of energy involving a radiation field is what we call electromagnetic radiation, and we'll dive into that idea a bit more deeply as we get deeper into Physics 2 next semester. Thanks for watching.